Tuition Mobile, quality e-learning experience on the go.
Good day and welcome to today's class. For our topic today, we'll be considering the sine rule. The sine rule, and then we're talking about deductions. How the sine rule was deduced, deduction of the sine rule. Okay. For us to deduce the sine rule, so we can prove to successfully prove that in a triangle, okay, the sine rule states that in a triangle that sine A, okay, is equal to B over sine B, okay, which is equal to C over sine C. Alright, we need the following. The following needs to be used to prove this. One, we need an acute angle. We need an acute angle triangle. Okay, and secondly, we need an obtuse angle triangle. Okay, I believe everybody knows what an acute triangle is. An acute triangle is less than or equal to 90 degrees. An obtuse angle is less than or equal to 180 degrees. Alright, so this is less than or equal to 90 degrees. Alright, and number 3, we need a right angle triangle. Number 3, we need a right angled triangle. Okay, and the first we said is an acute angle, an acute angled triangle, acute angled triangle. Okay, which we can draw as follows. Okay, and then denote as A, B, and C. Alright, good. And we draw a line to meet AD, and then we draw a line from A to meet at D, and then a line at B to meet at the midpoint there at E. Alright, okay, this we shall call the altitude. We shall call these lines the altitude of the triangle, the altitude of triangle ABC. That's what we call those lines. And we have to prove that AD is equal to AB sine B, okay, and is as well equal to AC sine C. Alright, okay, so if you observe carefully, you find out that the side AD is giving us the side BA sine B, okay, sine B here, right, the angle B there. Alright, okay, therefore all we are saying is that C sine B, knowing that our triangles are denoted in small letters as C and then A and then here B. Alright, so the side AB could be denoted as C sine B to be equal to AC, which is B sine C. Alright, so this implies that we can say that B over sine B is equal to C over sine C. Okay, alright, what if we take BE to be equal to BC sine C? Okay, right, BE, the line BE, okay, is equal to BC. B is equal to BC sine C. Alright, this is sine C for you. Okay, and y this is sine A. All right, and we say it will be equal to AB sine A. All right, that's our AB, and the side facing AB is AB is A, and so and the side facing A is small letter a. So BC, from the triangle you find out BC is equal to A sine C, and AB is equal to C sine A. Okay, and so we have a relationship here. From this point we can say that A sine A is equal to C sine C too. Alright, good. So therefore since from the first relationship we had that B sine B sine B is equal to C sine C, and then A sine A is equal to C sine C, so we can say therefore that A sine A is equal to C sine C, which is also equal to B sine B. So there's nothing but saying that A sine A is equal to C B sine B, okay, in the alphabetical order, and which is equal to C over sine C. All right, this is one way of observing this proof. A second way is by the use of an obtuse angle. We use an obtuse angle triangle, obtuse angled triangle, okay, and then we have the obtuse angle triangle as A, B, and C. Okay, we have A, B, and we have C. All right, we'll construct AD such that AD is perpendicular to BC. Construct AD such that it is perpendicular to BC, and so we have as follows. Okay, and so this is our AD. All right, okay, and then we'll produce perpendicular to BC, and then we'll construct BE to be perpendicular to AC. We construct BE to be perpendicular to AC. All right, so this is our BE, and then I let these lines join. Okay, so we have to prove that AD from the point, okay, we can denote our sides. This is side A, and this is side C, and this is side B, while this is side small letter d. Good, and this is side E. All right, so we continue with the proof. All right, let's prove for this that AB is equal to AB here is equal to is equal to sorry it should be AD is equal to AB sine theta. This is our AD. Okay, fixing this side is equal to AB sine AB sine B, okay, which is also equal to AC sine 180 degrees minus C. Okay, all right, let me make this look clearer and better. AD is equal to AB sine B, okay, which is also equal to AC sine 180 degrees minus theta. Okay, and so we have that AD is equal to C. Is that so? AD is equal to C. AD, that's the AD we have. Is it C or B? No, AD is equal to B. Sorry, let me check that word. AD, all right, is equal to B. B sine. Is that right? Okay, C sine B. Okay. Why the mix-up was C here, so the side fixing C is just this side, and so we have C at this point. Okay, all right, so we have that AB sine B is equal to C sine B. Okay, and which is equal to AC sine C. Okay, and AC is sine 180 minus theta at that point is equal to B sine C. All right, so therefore from this point we can say that B over sine B is equal to C over sine C. Okay, and from this line, all right, I think somehow you get it a bit mixed up because of difficulty in explanations. Okay, all right, let's try to find the other side, BE, using the same altitude. We try to find the BE side using the same altitude, and I believe this one will be simpler for you. All right, similarly, okay, by using the same altitude, by using altitude BE, okay, this implies that we have A over sine A, all right, to be equal to C over sine C. Okay, by using altitude BE. Okay, so we have that BE from this point will be equal to BE will be equal to sine A. We have A fixing this side, and so we have this part to be BE, and then we have BE sine BE will be equal to sine A here, and then BE. So how do we get BE is equal to the part facing C, and then this is C sine A, okay, which is also equal to the altitude on this side. Okay, sorry, this is C sine A, which is also equal to the altitude on this side, where we have that it is also equal to BE sine C. Okay, and therefore we can say C sine A is equal to BE, which is equal to A sine C. Alright, I know this will prove to be a bit difficult, but instead of being troubled by this, you can use the first proof. Moreover, the most important thing is just for you to note that the relationship between the sine rules is defined by the fact that each side is proportional to the angle of each side. Okay, that A over sine A side is a ratio of its angle, the ratio of the angle of A side, and A is equal to the ratio of the angle of B side and the B, and is also equal to the ratio of the C side and the C. Okay, alright, so let me keep thinking of how to make the proof easier before we go back to the proofs. Okay, so we'll be applying these rules to some simple examples, and then from there we'll solve, so you can see the applications of the rule. Some other thing you need to note is that the sine rule is used when you have two sides, and one angle, and when you have two angles and one side. Okay, note we apply sine rule, sine rule. We apply sine rule when you are given two sides and one angle, or rather when you are given two angles and one side. Okay, so these are conditions that make us use sine rule. All right, and so we will apply to some examples. For example, in a triangle ABC, A is equal to 54 degrees, and then B is equal to 67 degrees, and then the side A is equal to 13.9 meters. Okay, and then you attempt to find the sides B and C. So assuming this is our triangle, and then we have A, B and C, and then the side A is 54 degrees, and the side B is 67 degrees, and the side C is unknown. Okay, alright, and then you're told that A, small letter A, is equal to 13.9 meters, and you're told to find small letter B and small letter C. Alright, so how do we go about this? Remember from our sine rule, our sine rule states that the solution from our sine rule solution states that A over sine A, okay, that the sides of a triangle are proportional to the sides of the opposite angles, and so B over sine B is equal to C over sine C. Okay, so all we have to do is to choose any two that can help us quickly get the sides. Here we have A and B, we have angles A and B and side A, so we can substitute. Angle A is equal to, side A is equal to 13.9 meters, and then angle A is equal to 54 degrees, and then angle B is equal to 67 degrees, and so we have that A, which is 13.9 over sine A, is sine A, which is sine 54, is equal to B, okay, all over sine 67 degrees. Alright, so at this point we have to stop and then simplify the equations, the solution we have so far, and so you can cross multiply. You're free to cross multiply. Okay, and if you cross multiply, have 13.9 sine 67 degrees to be equal to B sine 54 degrees. Okay, so that we can make subject of formula, we can make B the subject of formula. So this is 13.9 sine 67 is given us 0.92 to 05, okay, to be equal to B, and sine 54 is given as 0.8090. Okay, fine. So this part you can find by multiplying 13.9 times 0.9205, and that gives you 12.7950. okay, and this side gives B 0.8090. okay, so that therefore B will be equal to 12.7950 over 0.8090. okay, so when we carry out that division, we have the outcome to be equal to 15.8157 so which is approximately equal to 15.82. right, so therefore side B, small letter B, is equal to 15.82. okay, so we go back to the triangle, and then we can write side B to be equal to 15.82. okay, 15.82. so we need to find side C. Alright, there are two methods to finding side C. Okay, side C can be found using two methods, and the two methods are: number one, it's either you solve by quadratic, or then you can as well use any of the two angles on the side and the angle for C to determine side C. Right, by Pythagoras. Okay, alright, let me look at that. By Pythagoras, we try to determine the side of C, knowing that the square of angles. Okay, I don't think that will really work for this. Okay, so let us use the other method to find for side C first, and then we can as well try the Pythagoras to see whether the two can rhyme. Okay, but let's use the authentic method, where we have C, and another problem we have with C is that we don't actually know the angle of C. But if you want to find the angle subtended at C, where we have theta, okay, where we have theta here, okay, we have the knowledge that the total angles in a triangle is 180 degrees, and so therefore to find the mixing angle is equal to 180 minus 67 plus 54. Okay, and so you have 180 minus 67 plus 54 gives a total of 121, and so we have 180 minus 121. Okay, so we'll have 59 degrees as theta. Okay, so therefore we can say that theta is equal to 59 degrees, and so we have an angle for C. And so whenever you are given two sides, you have a choice. You can either find the mixing angle, since you have a knowledge that the total angles in a triangle is equal to 180 degrees, so you can quickly subtract the sides given from 180 to get the mixing side. So we have that side C is equal to side C, big C, is equal to 59 degrees. Okay, so we can go back and look for side C with any of the side. Okay, C sine 59 degrees is equal to any of the side we like. You can as well use B over sine B, or you can use this. Okay, you can use C sine 59 degrees to be equal to A over sine A. Okay, why I'm making this illustration is just that I want to exhaust all the possible computations we can make to find the mixing sides and the mixing angles, so that we know which is correct and which wouldn't work. And so we become careful whenever we want to use any method. And so we have C over sine 59 for this to be equal to B over the side B is 15.82 and the angle is 67. Alright, so we have an angle of 67 degree, and then we have 15.82 as B, and so sine 67. And so on the next line we have C, we are sine 59 is equal to 0.8572. okay, is equal to 15.82 divided by sine 67, which is 0.90, sorry, 0.9205. fine. Alright, so you can cross multiply to, okay, so that you have 0.8572 times 15.82 to be equal to C and 0.9205. okay, so when you multiply this 2.8572 multiplied by 15.82 gives you 13.5609 to be equal to C 0.9205. okay, so therefore from this point C is equal to 13.5609 all over 0.9205, okay, which will give you a total outcome of 14.73. And if we decide to go by this method on the other slide, and so we have that C over sine 59 degrees is equal to A over sine A, and then we have A side A to be 13.9 and sine 54. Okay, we have 13.9 over sine 54. Okay, let's see whether it gives us the same thing. Already we have sine 59 to be equal to 0.8572. okay, this is C over 0.8572 to be equal to 13.9 over sine 54, which we have to be equal to 0.8090. okay, so we can cross multiply as usual, and so we have C 0.8090 to be equal to 13.9 and times 0.8572. okay, and so we have that C will be equal to 13.9 times 0.8572 divided by 0.8090. okay, all right, so multiply 13.9 with 0.8572, okay, and then divide by 0.8090, and then it gives us that C is equal to 14.73. okay, which is the same thing with the other method. Alright, I said we will also test the Pythagoras method and see whether it works here, and if it doesn't work, we will have in mind that we don't intend applying it whenever we have angles like this. And so could we say that C squared is equal to A squared plus B squared. Okay, ordinarily Pythagoras works for right angle triangles, so it wouldn't work here. Alright, thank you for being part of this class. Okay, before we end the class, let's take one more example and an illustration where maybe we are given two sides and one angle, so we know how to work it out when the equation comes in that form. Okay, let's take an example where we have two sides and then we are given one angle. Alright, example 2. Example 2, find the missing sides of the triangle. Find the missing sides of the triangle below. Okay, so and you are given this triangle. Okay, you're given this triangle where we have A, B, and C. Okay, and then we have that A is 86 degrees, and then small letter B is equal to 13 centimeters, and small letter A. All right, and small letter C, assuming small letter A is 17 centimeters. Okay, and then C, and then C is not given too. Alright, so you have that we have two sides and then two missing angles. Okay, theta and beta are the two missing angles. So how do we find this solution? Right, solution. Remember that we are given side A and sine A, so we can use side A as the reference point, and then which other side was given? Side B, and no angle was given. Okay, so this implies that we have A, which is 17 over sine 86, to be equal to B over sine B. Okay, so when we cross multiply 2, we have that 17 of sine B is equal to B sine 86. Okay, and then B is given as 13 centimeters sine 86. Okay, and so we can say that sine B is equal to 13 sine 86 all over 17. Okay, and so we have 13 sine 86 to be equal to 0.99, so we can write this as 13 times 0.9976, okay, all divided by 17. All right, and so when we multiply by 13 and divide by 17, we have an outcome. So we can say that sine B is equal to 0.7628. all right, so we can write that clearly on the next page. So we have sine B equal to 0.7628. At this point in time, what you do is to make B the subject of formula, and so you take division of signs on both sides so that sine can go out, and then you have B is equal to 1 over sine of 0.7628, and 1 over sine is equal to sine inverse, okay, 0.7628. and so sine inverse is obtained on your calculator by pressing shift sine, okay, shift plus sine, okay, and then impute the number you want to find, the inverse, the sine inverse, which is 0.7628, and then strike on your equality sign on your equality key, so that B then you have shift sign, okay, which will give shift sign of 0.7628, which will give 49.715, okay, which is approximately equal to 49.72 degrees. All right, so we can go back and then fix beta to be equal to 49.7 degrees, and so we go back to the whole triangles, and then to find C is very simple. C will be equal to 180 minus angle beta and angle A, okay, and then that means angle C, which we call beta angle, is equal to 180 minus 49.72 minus 86, okay, so we have 180 minus 49.72 and then minus 86 to give an outcome of 44.28. okay, so the angle on theta is equal to 44.28, and so we can use this information to find the side C. Okay, we can as well find its angle. Alright, since we have the angle of for C to be 44.28, so we can find the side C. The side C over sine C will be equal to A over sine A. Okay, and then it means we have C over sine of 44.28 equal to A, which is A is equal to 17 over 86 sine 86, 17 over sine of 86, and so you have C sine 86 to be equal to 17 sine 44.28, and so that C will be equal to 17 sine 44.28 all over sine 86. You can as well punch it into your calculator this way. Okay, you can use brackets to separate distinctively so that you don't make mistakes. Okay, so you can press 17 sine in bracket 44.28, okay, and then divided by, you insert another bracket after the division sign for this, and then you have sine 86, and then you close your bracket. just like we did there. And so C will be equal to 11.8978, okay, which is approximately 12. All right, so if those sides, okay, this gives us 12 centimeters, 17 cm, and then the rest. I think from this example you can see how the manipulations we are done to determine, even from when you are given an angle and a side, and then you were able to determine all the sides. Note that whenever it is stated that it is an isosceles triangle, then it means if two sides are stated to be sides to be equal, okay. Note, if it's an isosceles, that is, if it is an isosceles, okay, and with me, that is that two sides are equal, okay. You do not need to be told again that their angles will be equal to, okay, their angles too will be equal, okay. Fine. So if two sides are equal, the angles guiding the two sides will also be equal. All right, in our next class we'll be talking about the cosine rule, and then we'll take the proof, and then we'll kick off with doing some other examples. Have a nice day. Bye.